Hi, this is Javin, a chemical engineer by profession, going to continue today's topic, thermal radiation. Now, what is that? Thermal radiation is electromagnetic radiation generated by thermal motion of particle in matter. Thermal radiation is generated when heat from the movement of changes the material electron to proton in common form of matter is converted electromagnetic radiation. All matter with temperature greater than absolute zero emit thermal radiation at room temperature. Most of the emission in the infrared spectrum particle motion result charge acceleration of dipole oscillation which produces electromagnetic radiation. If radiation object meet physical characteristic black body in thermodynamic equilibrium, the radiation is called black body radiation. Planck's law describes the spectrum, the black body radiation, which depend solely on the object temperature. Wind displacement law determine the most likely frequency of the emitted radiation. The Stephen Boltzmann law gives the radiation intensity. Thermal radiation is also one of the fundamental mechanisms of the heat transfer. Now it's over. Thermal radiation is the emission of electromagnetic wave from all matter that has temperature greater than absolute zero. Thermal radiation reflects the conversion of thermal energy into electromagnetic energy. Thermal energy is the kinetic energy of random movement of atom and molecule in matter. All the matter with non-zero temperature is composed particle with kinetic energy. The atom and molecule are composed of charged particle, the proton and electron. The kinetic interaction among matter particle result charge acceleration and dipole oscillation. This result the electrodynamic generation of coupled electric and magnetic field resulting in the emission photon radiating energy away the body. Electromagnetic radiation include visible light with propagate intensity, the vacuum. The characteristic thermal radiation depend on various property of the surface which is emanating including the temperature, spectral emissivity, express Kirchhoff law. The radiation is not monochromatic. Example, it does not consist only single frequency but comprises continuous spectrum. The photon energy is characteristic spectrum is the radiating body, its surface area, thermodynamic equilibrium and surface has perfect absorptivity, all wavelength and it's characterized the black body. A black body is also perfect emitter and radiation of such perfect emitter is called black body radiation. The ratio of the body emission relative to the black body is the body emissivity, so that black body has emissivity of unity means equal to 1. Absorptivity, reflectivity and emissivity. All body are depend on the wavelengths of radiation due to reciprocity, absorbivity and emissivity of any particular wavelength are equal and equilibrium. A good absorber is necessary, good emitter and poor absorber is poor emitter. The temperature determines the wavelength distribution of electromagnetic radiation. For example, white paint diaphragm on the right is highly reflective. The visible light reflectivity about 0.80 and so appear, while the human eye due to reflecting sunlight which has peak wavelength about 0.5 micrometer. However, the emissivity of temperature 5 degrees centigrade means 23 degree Fahrenheit, peak wavelength of 12 micrometer is 0.95. Those thermal radiation is appear as black. Now, the distribution of power in black body emit with varying frequency is described Planck's law. Any given temperature, there are frequency at which power emitted, the maximum wind displacement law. In this fact, the frequency inversely proportional to wavelength indicate the peak frequency is proportional absolute temperature. The black body, the phosphorus of sun and temperature approximate 6000 Kelvin body, the phosphate of sun emit radiation principally the human visible proton electromagnetic spectrum. Earth atmosphere is partially transparent. to visible light, and light reaching the surface absorb reflected Earth's surface emit absorbent radiation. Approximate behavior black body 300 Kelvin with spectral peak. This lower frequency, the atmosphere is large opaque and radiation from Earth's surface is absorbed or scattered by the atmosphere through about 10% of radiation escape into space, most of absorbed, then re-emitted atmospheric gases. This is spectral selectivity of the atmosphere. Now, that is responsible planetary, the greenhouse effect contributing global warming and climate change general, but also critically contributing the climate stability when the composition of property atmosphere are not changing. Unlike conductive and convective form, heat transfer thermal radiation can concentrate the tiny spot of using reflecting mirror which is concentrating solar power. Take advantage of instant mirror. Fensel lenses can also be used to concentrate radiate energy. The principal kind lens can be used, but only Fensel lens design. Practical very large lenses. Either method can be used. Quickly vaporize water into steam using sunlight. For example, the sunlight reflect the mirror heat solar power plant, and during the day it heat water to 85 degree Fahrenheit. Now, surface effect. What is that? Light color and also white and metallic substance absorb less than the illuminating light. As result, heat up less. Otherwise, color make little difference. Regard heat transfer between the object everyday temperature and its surrounding since dominant emitted wavelength now were near the visible spectrum rather than far infrared emissivity. Those wavelengths are largely unrelated visual emissivity. In the far infrared, most objects have high emissivity. Those except sunlight, color of clothing make little differences. Regard warmth. Likewise, paint, color, houses make little differences. So wavelength except the painted part is sunlight. The main excitation, the shiny metal surface, which have lower emissivity, both visible wavelength and far infrared. Such surface can use to reduce heat transfer both direction. The example, multi-layer insulation can use insulate spacecraft. Lower emissivity window is the houses. They are more complicated technology since they must have low emissivity at thermal wavelength while remain transparent to visible light. Okay, now is properties. There are four main properties that characteristic thermal radiation. Thermal radiation emitted body at any temperature consists wide range frequency, the frequency distribution given by Planck's law, black body radiation, an idealized emitter. The dominant frequency ranges emitted radiation shifted higher frequency temperature to emitter increases. For example, red hot object radiate mainly long wavelength of the visible band and heated further, it being emitted discriminate amount of green and blue light spread frequency entire visible range causes white to human eye. White hot, even white hot temperature 2000 degree Kelvin, 99% energy radiation is still infrared. This is determined when displacement low in the diaphragm and peak value the curve move to left, temperature increases. The total amount radiation frequency increases steeply as temperature rises. Goes temperature rest to 4. This is temperature, absolute temperature of the body and object temperature, kitchen, oven and twice the room temperature, absolute temperature scale 600 Kelvin versus 300 Kelvin. Radiate 16 times much power per unit area and object temperature of the filament, light tube and light bulb roughly 3000 degree Kelvin, 10 times room temperature radiate 10,000 times much energy per unit area. The total radiate intensity black body rises horsepower absolute temperature expressed Stephen Boltzmann's law. In the plot, the area under each curve grows rapidly, temperature increases. The rate of electromagnetic radiation emitted at given frequency is proportional amount absorption that would experienced by the sources. Property known city, those surfaces that absorb more red light thermally radiate more red light. This principle applies to all property wave including wavelength, direction, polymerization and even Chlorhensen. Hence, so quite possible the thermal radiation which is polarized, coherent and directional through polarized, coherent form. The fairly rare nature far sources, the wavelength and its near field and far field are the general property thermal radiation described Planck's law apply linear dimension all part consider well radial curvature of the surface, large area compared to wavelength, the ray considered typically 8 to 25 micrometer, the emitted 300 Kelvin. Indeed, thermal radiation, as discussed, take only radiative wave, electromagnetic radiation, its account of more sophisticated framework involve electromagnetic theory must be used. Similar, distance from the thermal sources, surface near field radiated heat transfer, for example, all through far field thermal radiation, distance from surface more wavelength is generally not coherent to any extent near field thermal radiation, radiation of distance, fractional various radiation wavelength, the exhibit degree of both temperature and the spatial coherence. Now Planck's law, thermal radiation has been challenged in recent decades by prediction and successful demonstration. The radiative heat transfer between objects separated nanoscale gave the deviate significantly from the low prediction and this deviation is especially shown up to several order in magnitude. Those emitter and absorber support surface polarization mode can couple through the gap separating cold and hot objects. However, take advantage surface polarization mediated near field radiative heat transfer. Two objects need to separate ultra narrow gap, the order micron, even nanometer. This limitation significant complicated practice design. Another way to modify object thermal emission spectrum by reducing dimensionally the emitter itself, the approach built upon the concept, the conflicting the electron in quantum well and wire and dot, Taylor thermal emission, engineering confined photon, state the 2 and 3 dimensional proton trap including well, wire, dots, such confinement concentrate photon state and enhance thermal emission at select frequency to achieve required level photon confinement. The dimension radiating object should be ordered to below the thermal wavelength predicted by Planck's law. Most importantly, the emission spectrum, thermal well, wire and dots deviate Planck's law prediction not only near field but also far field which significantly expand range application. Now, is interchange of energy. What is that? Thermal radiation is one of the three principal mechanisms heat transfer. It emit emission spectrum wavelength electromagnetic radiation due to object temperature of the mechanism, their convection and conduction. The radiation heat transfer characteristically different from the other two in that it does not require medium and in fact reaches maximum efficiency in a vacuum. Electromagnetic radiation has some of proper characteristics depending on the frequency and wavelength of radiation. The phenomena of radiation is not yet fully understood. Two theories have been used to explain radiation, however neither theory is perfectly satisfactory. First, the earlier theory which originated from the concept hypothetical medium referred ether. Ether suppose field evacuated, non-evacuated space, transmission of light, radiation, heat, they are allowed at propagation. The electromagnetic wave in ether, television and radio broadcasting wave, the type of electromagnetic wave, the specific wavelength, all electromagnetic waves travel same speed, therefore shorter wavelengths are associated with the frequency. Since every body fluid is submerged in ether due to the vibration, the molecule as body, the fluid can potentially initiate an electromagnetic wave. All body generated and receive electromagnetic wave at the extent of stored energy. The second theory, radiation, based on quantum theory, which was first offered maximum Planck in Issue 1900. According to this theory, energy emitted by radiator the not continuously but each form quanta. Planck claimed that the quantity, the different size, frequency, vibration has similar wave theory. The E is found of expression E is equal to hv, where h is Planck's constant and v is the frequency. Higher frequency are originated higher temperature and create increases energy quantum, while the propagation of electromagnetic wave of all wavelengths is often referred radiation. Thermal radiation is often considered to visible and infrared region. For engineer purpose, it may be stated the thermal radiation is from electromagnetic radiation, which varies nature of surface and its temperature. Radiation wave may travel unusual pattern compared to conduction heat flow. Radiation allow wave to travel from heated body through a cold, non-absorbing, partially absorbing medium, such a warmer body. Again, this is case the radiation wave travel from the sun to earth. Radiation heat transfer process where heat waves are emitted that can be absorbed, reflect, transmitted through cooler body, sun heat, earth by electromagnetic wave, hot body emit heat wave. Okay guys, this is up to radiation. We have seen so many things up to thermal radiations in a very brief manner. Next chapter we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.